Hi, all. I was going through this worksheet, and the first three or four that I was going through and leaving comments on, I found myself leaving the same comment over and over again. So I wanted to just go through these together. I post this on Google Classroom. You guys can use it to either check your answers or use it to guide you throughout this process. I realize not everyone has turned them in yet. That's fine. You can use it to help you, with the answers. You can guess and check as you go, and use it to complete the problem before our quiz tomorrow. So here we go. Number one, a water purifier removes 2/5 of the contaminants each hour. The purifier is used to filter water that contains 300 grams of contaminants. Write a function that gives the remaining amount of contaminants in grams. So it's called C of T. T hours after the purifier started filtering water. This one, they gave you a hint. Use the equation C of T equals A. A is the initial value. Times the quantity 1 minus R, where R is the rate. So when we take this and we plug this in here, so they told me to start with C of T. C of T equals my initial value, which is 300. We multiply that by 1 minus the amount that it's losing each hour is 2/5. So we subtract 2/5 out, and it's raised to the T power. If you want to clean that up and take the additional step of taking 1 minus 2/5, so that would be 3/5, and again, raised to the T power. Either of those two answers is correct. Next one, a 2 kilogram sample of radioactive mass loses 1% of its mass every decade. Write a function that gives the sample's mass in kilograms, R of D, after D decades. Okay, so we start with R of D. Same concept as up above. It's losing 1% every decade. So this is exponential decay, and we do the same exact process. We start with the initial value. They told me it was a 2 kilogram sample, so we start with that. We go 1 minus the rate that it's losing it is 1%. As a decimal, that's 0.01, and that's raised to the D power because we're talking about decades in this case, not just T time. You can leave it like that, or you can take the additional step of subtracting that. 1 minus 0.01 is 0.99, and that's raised to the D power. So there's the first two. All right, so now if we take a look down below at the next one, there is a video link to this one. So if we take a look here, use the function below for problems 3 through 5. What is the y-intercept of the graph of f of x? Hint, look at the initial value in the equation above. So what we have here for these is where the initial value is, that's where f equals 0. Or excuse me, where x equals 0. So f of 0 equals 4. And if you remember, before we went on this extended break here, we talked about things in scientific notation here. You can write that as input and output. So the input would be 0, the output would be 4. So your initial value, your y-intercept, is 4, because that's where the graph touches the y-axis. Find f of 1. So now we take this, and everywhere we see x, we plug in 1. So 4 times 1/2 to the first power. Well, anything to the first power is the base. So in this case, it's 4 times 1/2, and half of 4 gets us 2. So if we plugged in 1, we got out 2. So where is f of 1? That's 2. So which of the following graphs shows f of x? So if we scroll down here, we know that 1/2 is less than 1. This is exponential decay. So because it's exponential decay, I can cross out A because that's exponential growth. I can cross out D, that's exponential growth. C is not one that we have seen before, but just to confirm, the two values we're looking for 0, 4, we're looking for 1, 2. 0, 4 is right here. 1, 2 is right here. We can see those 2 points appear, so the correct answer is B. All right, next page. Now, instead of talking about graphs, we're talking about the table. What is h of 0? Well, again, h of 0 is where x equals 0. Gives you a hint here. Look for 0 in the x column, then read across to find the y value. Where is x equal to 0? It's here. We go across. That means h of 0 is 12. What is h of 1? H of 1 is here. We look across. It's 3. Okay, so now the two values that we have 0, 12, and we have 1, 3. If we take a look, as we scroll down and write the equations, number 8, write the exponential function h representing the table of the form h of x equals a times b to the x power. So h of x equals the initial value we just figured out, that was 12, because that's where x equals 0. Now, to figure out our decay factor, and this is decay because we went from a larger number to a smaller number, you have to ask yourself, what did you divide by to get from 12 to 3? Well, if you divide 12 by a number, it's 4. That gets you 3. Well, dividing by 4 is the same as multiplying by 1/4, and it's raised to the x power. So there's my equation. To test this, if I plug in 0 for the exponent Anything that's a non-zero base to the 0 power is 1. 1 times 12 is 12. So that checks out that answer. If I plug in 1 here for x, that's going to be 12 times 1/4 to the first power. 1/4 to the first power is still 1/4. And 1/4 of 12 equals 3, confirming this answer here. A lot of confusion on that one, so I wanted to make sure I went through those ones. Okay, how about this one? Same kind of idea, except now we're using the graph. What is g of 0? Well, g of 0, where is x equal to 0? X is equal to 0 right here on the y-intercept, so g of 0 is 6. What is g of 1? Where is x equal to 1? It's right here. That's 2. Write an exponential equation, so we got g of x equals the initial value, where x is 0, is 6. Ask yourself the question, 6 divided by what gets us 2? Well, that's 3. Dividing by 3 is the same thing as multiplying by 1/2 raised to the x power. And you can confirm those by plugging in 0 and plugging in 1. I promise you will get the exact same answer. Okay, now, linear versus exponential growth. Michael receives $1,000 deposits in a bank account that grows at a rate of 2% each year. This is being multiplied. If it grows at a rate of 2%, that is based off of the previous one, that has to be exponential growth. So this is exponential, which means when we write this thing in exponential form, they want us to write it as m of t. M of t equals the initial amount we said was $1,000. It's adding, growing at a rate of 2% each year, so that's 0.02, and it's after t years. You can leave it like that, or you can clean it up to 1,000, 1.02 to the t power. Next one, she earns $50 in deposits in her checking account. If she deposits it in her checking account, she is adding that to her total. When you are adding, that's linear. Linear equations are of the form y equals mx plus b. So b is the initial amount here. In this case, she started with 600. She's adding $50 each week, or excuse me, each week. So that's 50 goes out in front of x. All right. If you have any other questions on these, please feel free to ask. Again, text, call, email, whatever it is. If you have issues, let me know, because we do have a quiz tomorrow or Friday. So let me know what issues you have. Thanks, guys.